A very important term we need to understand is the floodway. The regulatory floodway is the channel of a river or other water course in the adjacent land areas that must be reserved in order to discharge the base flood without increasing the water surface elevation more than a designated height. Now, right now you're saying, wow, that's a lot to remember, it's kind of confusing. Guess what? I'm going to show you a graphic that makes it a lot easier. Yeah. So I'll give everybody a minute to copy some notes down, and then we'll look at the picture and get an idea. And I can always come back to this. And as I said before, I'm going to be here tomorrow too because I'm proctoring the exam. So if you think of anything tonight, we plan for what, a 2-hour review session in the morning tomorrow. So we'll run that almost like this, open forum. So feel free to bring questions. And if you want to see any of these again, I can bring it back up for you. So here's the graphic. I'm a picture person. I like seeing graphics and things. This is the easy way to understand it. So this is my floodway. So this is, now visualize, this is my river or stream flow in this direction. It's a cross section. It's a profile, cross view. Here's my stream channel. Here's my water level. Here's the one bank. Here's the other bank. So each one of these, so my floodway is the area where my water always is, essentially. And that's defined by here. So here's the area where my water always is, and that's my floodway. So the areas on either side of the floodway we call the flood fringe, or the floodway fringe. They're the fringes on either side of that main channel. Now, what do you notice about these two fringes?
They have different height.
They have a height, and they're also not symmetrical. They do not need to be symmetrical. A lot of people always confuse it. They're like, but they're not even on the same side. They won't be. Does anybody go canoeing? If you've ever gone canoeing down meandering rivers, you have the slip-off slope and the cut-off slope and some of these huge build-up sandbars and some of the deep part. Almost every river is like that. Most rivers are not symmetrical, so don't let it confuse you when you see an uneven area. It still counts the fringe and the floodway and the fringe on each side. Altogether, that is my 100-year floodplain. The general idea here is if this area floods over, where does that water go? It goes up over the fringe area.
Does the floodway also protect the fringe? Will they always delineate between the fringe and the floodway? Because I've seen the documentation in the state floodway, sometimes they talk about from fringe edge.
Well, and they have to define that. And one of the things, that brings up a good point, one of the things to remember about this is not limited by scale. So this here, say it's a Mississippi River, that could be a mile wide, then each one of these fringes could be another mile or two wide. Don't always depict that small little river running behind grandma's house that has water in it to this level. This could be that fringe, to be that floodplain, this could be miles across. So here's our fringe, here's our floodway, here's our fringe. Now, can I build something in the floodway? Am I allowed to build in the floodway?
Yes.
True or false? How many say true? How many say false? Those of you that said false, you should have said true. You can indeed build in the floodway. There's nothing from the NFIP that says you can't. But guess what? We really discourage it. We don't want people building in the floodway. They can, but we really try to discourage them. If they do want to construct something in the floodway, what do we require of them to submit? You ever heard the term no rise? Now there's no specific certificate. FEMA does not have a no rise certificate. The no rise is an engineering study performed by an engineer that determines anything that's built in this area is not going to cause the water to rise. So they named it a no-rise. What a novel concept. They basically said, hey, you're going to generate this study. and we're going to determine that by you building something there, and think about it, it's me saying I have this river flowing. If I build something there, that displaces some water at some point in time during a flood event. Is it going to cause the water to rise for other locales? Well, it is, but what I want my no-rise study to delineate and to show me is that it's not going to rise to a certain maximum that's going to affect other structures, property, or people in that area. That is the term surcharge. What by the NFIP is the maximum rise of surcharge allowed? 1 foot. And now we're going to turn all this back into a map reading skill here pretty soon when we see the floodway on a map. The important things to remember in this is we've basically taken this definition, kind of arduous, kind of cumbersome, and turned it into this picture. A little bit easier to remember.
Okay, so I can also build the encroachment area. Okay, I can build in the encroachment area as long as I'm not increasing the flood bay no more than 1 foot. Or per county regulation, whatever. But I can also,
Be clear on that though. The 1 foot is a FEMA regulation.
all right, but if I build in a floodway, say I want to go beyond the encroachment, build in that floodway, I can't have any rise.
Correct.
No rise if I build in that. It has to be federally.
But you're still, let's see right here, the surcharge is not to exceed 1 foot or lesser. So I can say it's 6 inches if I want to in my state. That's why you supply the no rise. If you build something there, the water's going to rise. It has to. The water, you're displacing something.
Right, so why the no rise? Why not say rise no more than 1 foot? No
Well,
rise doesn't really.
Well, they call it a no rise because the idea is you're delineating how much the surcharge is going to be
It's
raised.
confusing because you can encroach as long as you don't increase, but when they talk about building into floodway, there's a no rise that's meant 0 to me. But it's really no more than 1 regardless of whether I'm building in a floodway or I'm building in a road.
Correct, because the idea is you're trying to show that whatever you're constructing is not going to raise it more than 1 foot. Now you notice here that the 1 foot is the FEMA requirement. Your state could have less. There are some areas that have a 0 no rise, which is saying just what you said, which means, so instead of, and I think they've done some of that on the semantics, because if I tell somebody you can't build in the floodway at all, they're going to be like, hey, that's my property, you're taking my property from me, these are my rights. But then if you say, hey, you can build there, but you can't have any rise, then somebody's stuck with saying, well, how am I going to build this where there's no rise? It may have to be an elevated structure. I may have pilings or piers, and that's the only element that's in there, and then maybe an engineer can calculate and say, okay, that won't cause the water to rise in. But otherwise, if I stick a structure, if I stick a slab on grade structure right here, as the water hits it, it's displacing some water. Whether it's inches or feet is dependent on the size of the structure. What's the other thing when we talk about some structures? Anybody know what the other calculation that we work on? Starts with a B. We want to make sure the building doesn't float. We do buoyancy calculations. And those are important when we talk about flood-proofing a structure. And we'll mention that in a little bit. The idea, if I'm going to flood-proof a structure to make sure water doesn't come in, I also have to make sure it's not going to float away. So as I said, this becomes this in a little bit easier format to see, in a graphic format. So, next quiz question of the day. Does anybody know what the bottom of the stream channel is called?
Lake
It's close.
Squally or something like that.
Close. It's the Floodway. Believe it or not, that's one of those little trivial things. I challenge you to try to.
all the way to Missouri.
I challenge you to try to incorporate that into your next party conversation. Good luck if you can do that. So it's the lowest point at the bottom of the stream channel. So the floodway data table, and we're going to see how these correspond to our map reading that we've already touched upon. The floodway data table provides information for each cross-section. Things like the distance, which is the stationing, the cross-section width, the cross-section area, the mean velocity of floodway flow in FPS, which is what? feet per second at the cross section, and the BFE at the cross section, and the increase at the identified cross section. So those are all the important things that we're going to see in the floodway data table. What document is the floodway data table in? Flood insurance study. Yeah. We use those. Oh, what's that?
He gave me a dirty look. I studied.
We use those in conjunction. The map and the flood insurance study are your friend because you've got to use them in conjunction to answer a lot of not just the test questions, but our general knowledge, general information of floodplain management comes from both. If you're ever at a municipal office seeing the floodplain manager or something and all they get out is the map and they don't get out the study, I would challenge what their actual data is going to be, because the study gives us all this information that the map doesn't necessarily tell us. Think about it. If I look at the map, I've got the geographical, the geospatial information, but I don't have all these specifics. So if I want to know the specifics of a cross-section, and I look at the map, I'm like, I want to know the details of what's right there. If somebody's looking at buying a piece of property and they point on the map saying, I'm buying this and here's the cross-section, I need to be able to use the flood insurance study to be able to generate that information. So here's our floodway data table. Hydraulic analysis represented each cross-section. I'll bring a larger picture up for you. Now the important thing to remember when we're using these, it's kind of blocked out by the bottom of the screen here, but make sure you're using the proper data table for the actual water body or river that you're using. See how this one says Rocky River? For every study performed for a given area on a given firm, there's an individual data table for that specific floodway. So don't just assume that the first one you get to covers all the rivers on that map. There's more than one. In this case, it's Rocky River. And we have this highlighted because this is the regulatory. So if somebody asks you for the regulatory BFE, what do you think that number is if I look at the firm? 10. Because it's rounded up, so it's 10 on the firm. But if somebody says, I want the accurate regulatory number, I want to give them 9.9.
And that would be the flood insurance study, same number.
Correct. Yeah, because that's where this comes out of, the flood insurance study. So, and we'll see how these tie into this cross-section on the map. And if I read the map, that's going to tell me 10. It's correct, it's just a rounded number. But if somebody says, well, I want the regulatory number because I'm really cheap, I don't want to spend any more money on elevating the structure than I have to, what's the minimal I can build at? 9.9.
So what are the with and without floodway numbers?
Oh, we'll cover those. So if I ask you, or if I look in here, is this cross-section in the floodway? If it's without a floodway, it's typically the same. It's not always the same. It's typically the same as our regulatory BFE. If I'm in the floodway, they've rounded them up here, but notice some are the same. And then this goes to what our increase is, or what our elevation increase is for that amount. And then we'll look and see in a minute where these respond or where these relate to every specific cross-section. So when we talk about this analysis, we've heard the term cross-section before. It's important to remember cross-sections cover riverine areas, rivers and inland. Transects are for coastal. So this whole time we're talking about riverine, we're talking about cross-section. I've got something that's delineating a river, a stream, some kind of water body that's inland. If I'm talking about on the coast, it's a transect. So here's our cross-section. So when we look at this, and we're going to look at these in detail, so don't feel that this is the only slide. But here's our same basic delineation we just saw, the floodway. Here's our fringes. You'll see these lines drawn on here, and I'll explain what those are. So here's our floodway. Here's our fringe area. What is that whole area called if I go from one fringe, including the floodway, and the other fringe?
100 year.
That's my 100-year floodplain. That's my whole floodplain area. We see our 1 foot max surcharge. So this is the profile of it. So guess what? This is this on the firm. And this is this in the floodway data table. So when we look at all these different graphic representations, if I look at each one of these on one piece of paper and I'm not relating it to the other two, it's kind of way out there. Like, where is this coming from? What is this used for? But all these are the same thing in just 3 different methods.
Your floodway is between the 2 solid red lines, right?
Correct. And on this map, here's my 2 solid red lines.
Yeah.
Well, obviously they're not straight because the river's not straight. But we have our cross-hatching delineation from the floodway, and we'll see that again. And how did we know that was the cross-hatching delineation that's on the floodway?
It's on the.
It's on the legend in the map, and we're going to look at that again. But if there was any confusion, I would just look back at the legend and go, hey, that's how that works. So this is this right here. So when we talk about cross-sections, we've heard that term several times. There's our cross-section. On the firm, on the flood insurance rate maps, cross-sections are always shown in hexagons. And they always start with letters. I say start because they go A through indefinite, however many cross-sections there are. If you have more than 26, it would restart at AA. I haven't really seen too many where you have more than 26. But they're always lettered, and that's essentially what it is. It's a cross-section of that river or stream.
The point between the 2 A's is the 100-year floodplain.
Correct. So if I had this fringe, I don't want to say the point between the 2 A's, because if I measure it on the map, I'm not measuring the line here, I'm measuring the red lines here.
Between the 2 little red lines.
Correct. Yeah. So here's my floodway, here's my fringe, here's my other fringe. So essentially between this red line and this red line is my 100-year floodplain. So it's just like what you said. I just don't want to say it's between my 2 A's because I don't want somebody to measure. If somebody says, what's the width of the floodway here, don't measure from A to A, measure from line to line. So we just said that on the map, the cross-sections are in hexagons. So what are my lines showing here? Guess what? That's the cross-section in the data form on the floodway data table. So A, delineated here, is A on this table. If you just look at the map, or you just look at the floodway data table, sometimes it can be unclear. If you put them all together, hopefully it starts to tie together. Yes?
I have a question for you. Wouldn't it be the little black lines on the outside?
Her question was, would it be the little black lines on the outside?
Like to measure the 100-year?
For measuring the 100-year, you could, and this is kind of a quote gray area, sorry, no pun intended, only because right here we show zone X unshaded. So yeah, so you're right. So if you wanted to really follow the exact detail, you'd say it's from the black lines.
Okay.
Here they have this zone X or zone B unshaded, delineated by that. On many maps you may not have that because you may not necessarily, it goes back to what Kurt asked.
Well, yeah, zone B though is between 1 and 5.
Correct.
It's shaded. If it's saying zone X is unshaded, but it's a B, so that's counter to truth.
Only because each side, here they've determined each side of this stream area is different. And that's one of those where that goes to the depth of almost like, what's it look like in real life? What's the topography? What were the historical events?
But the information you need would reference table A, and there's your distance and everything that you need right across the table.
Correct. And I totally see what you're saying.
Yeah.
Your debate and point, those like PhD material. You know, if somebody asked you that, that's the kind of stuff you could write a dissertation on how any specific area was deemed a B unshaded X versus C unshaded X for a specific area of geography. You had a question too, didn't you?
Yeah, I pretty much answered it. I was just wondering which red lines you meant when you were doing your measurements.
Yeah, this was the floodway, and she's actually,
Fringe
she's
to
got
fringe?
she's got the exact point here. If I wanted, I'd want from the edge of the fringe.
Everything inside the fringe is a 100-year floodplain. Outside of it would be.
It could be this kind of thing here,
Just based on
unshaded X, B.
Okay.
500
Yeah.
year, would that be the 500 year zone
Okay.
then?
No, it's not
Destination.
so 500 years old.
could be 500 a year, but it's not always 500 a year. Because that's essentially what Kurt's asking, is it always a 500? And that's going to depend on how they have it.
My mistake.
Yeah.
I'm bold.
Wow. And that goes to how they have it deemed as shaded or unshaded.
That gray area again.
Yeah. We're talking about some really finite analysis and details to get to that point, though. But the idea here is to show that when you have that cross-section, it relates specifically to that cross-section on the data table. So, say for example right here, if I wanted to know the exact width, like his question was, if I wanted to know the exact width of that cross-section, what do? Do I measure that?
No, you gotta look right there.
Yeah, exactly.
There are no scale rulers there.
Right. We don't have to measure it. If somebody knows I want to know the exact width of that cross-section, I'm going down here and I'm saying it's 115 feet wide. Yeah.
So if we were to get a question like this in the exam, we will be giving this information to answer it?
Well, yeah, they give you the map, the flood insurance study and everything. But I mean, that's a viable question. Somebody could say, what's the width of cross-section A?
I don't know.
Don't feel that like, oh my gosh, they didn't give me a ruler. What do I do here? I'm lost. We don't need a ruler. But that's when you have to know that you have to go to the floodway data table in the flood insurance study to get that number. And there it is, right there.
What is the distance?
115.
No, that's the width. What's the number to the left?
Oh, the distance, we'll see that in a minute. That's the distance down
Downstream,
the
right?
stationing. Yeah, because you can't see it from this picture, but we'll see where the B's and C's are. So as you go downstream, you'll see subsequent cross sections. Now, the one thing I will caution you on that is you have to make sure you notice what the superscript is, because it may not always be in feet. If we're talking about a large-scale map, it may be in miles.
It may be a mile.
Yeah. So here you notice they say width in feet, but if we're talking about a large-scale map, that may be miles downstream. So don't just assume it's feet. And I would almost assure you that this one isn't in feet because it says 4.3 and then B is at 5.5. That would mean the cross-section is right here, and do we see that? No. So distance very well could be miles downstream.
Distance from
one point to the.
right from A to B, B to Z.
And good. That's a good question. It's not distance from point to point. This is distance from the original stationing.
Oh.
And that'll tell you where it's either at the confluence, where the river is
We'll
defined.
know where that point is.
Yeah,
Okay.
there may be a reference mark, there may be a benchmark,
Okay.
and that's all delineated. I mean, there's no way you can ever
Right.
guess at that, but it'll tell you where that's at.
Okay.
So on the flood insurance study that I printed out for
Flood count.
USA, it does, Jim just noticed, it does say on here, delineates down here, feet above county boundary. Oh, that's,
Is it feet above county boundary, or is it feet in distance from?
it says feet above county boundary.
As the superscript, which is weird.
Yeah, and that actually may be an error, because think about it. If you have this one here, if your distance is downstream is 4 feet,
Yeah.
your next one's not going to be 5 feet, it'd be right next to it. Yeah, that superscript, actually, it might supposed to say miles, whatever the increment was.
Mike, I got a
So
question
tell
for
me
you.
that.
Should we have?
Yeah, it'll say that.
Should we have picked those up on the back table or?
What's that? If you want to grab one, in fact, I think we're probably supposed to take a break soon anyway.
2:30, Mike, if you're ready. Yeah.
Yeah, you want to do that? Pick one up, because a lot of this now we're going to start talking about maps and all that. Pick those up, start to familiarize yourself.